Hello guys, so welcome again to another video. So in this video, we're gonna see our first complete, assembly code. And we're gonna check, the main parts of any assembly code, the memory segment, the code segment, how to start the code, how to end the code, all of that. But first, we should have some definitions, some, introduction about what, a code looks like. First, we have what's called data definition or data definition. So in assembly programming, and a statement that defines some data is called data definition, which basically allocates some part of the memory, for some variable. And it has some syntax or some form to write, like adding a name, then a directive to, tell the assembler this is, a data, then initializer to initialize the, the data values. And you may, for example, in an array or something, you might have, multiple locations. So for each location, there will be some value. So you should separate them, by a comma. So variables, that you're gonna define in this data segment are based on assembly built-in data types that we're gonna explore in minutes. And as I said, all such, definitions or data definitions should be in the data segment. And we define for the assembler the part of the code that defines the data with a keyword .data, like this one here. Okay, and as we will, as we will explore in minutes, .data is a directive. Okay, of course, we didn't explore such directives yet, but we're going to explore them today. So, what is directives? So, a directive is basically a command, but this command is for the assembler. So, the assembler will, once it sees one of these directives, it will, interpret it in some way based on the directive. And they are very similar to preprocessor directives in C++, like, for example, hash include. Directives are used to define variables, macros, and procedures. Procedure is just like a functions, as we will see also at the end of this, lecture. Examples of directives like .data, which defines a data segment. So we are, once we write .data, we tell the assembler that the following will be part of the data segment. D-word, which means double word. So this defines that, this variable, for example, is double word, which means the word is 16 bits. So this variable will be 32 bits. End B, which means end procedure. So this is also a directive that tells the assembler this is the end of some procedure. Okay. Here is, some data types, not all of them, okay, but these are the most famous. We can say most famous or most well-known, the ones that you're gonna use most of the time, like byte. Byte, of course, means 8-bit unsigned integer. S byte means the signed byte. So signed byte is, 8-bit signed integer. So the first one is unsigned, the second one is signed. Word is 16 bits. Signed word means 16-bit signed integer. D word, which means double word, this is 32 bits unsigned integer. SD word means signed double word, which means 32-bit signed integer. And finally, if you have some real values, we define them with real 4. And real 4 means 4 bytes. 4 bytes means, 32 bits. So 32-bit IEEE short real value. Initializers. So initializers are basically when you define some variable, you might initialize this variable with some value. So so this is basically the initializers. Okay. So for example, you might define some variable and add to it like 0, for example. If you have multiple, values like an array which with multiple locations, you must define initial value for each one of these locations. You put, comma to, to differentiate between initializers, or you add multiple initializers. Okay. If you don't want to initialize some variable, then you put, the question mark. So in any case, you must put initializer. Even if you don't want to initialize some variable, you put, a kind of initializer that tells the assembler that there is no initialization here. So you put, the question mark. And of course, very important to note here that when you have some type, like for example, word, then the initializer should match this word. So the value that you put should be, less than or equal to, the size of the variable. So for example, if you define some variable that's like a word, which means 16 bits, then you can put for it, like 8 hexadecimal, for example, because 8 is basically 4 bits. Then you can add 4 zeros. This will be 8 bits. You can put 18, which means 1000, and and here you have 3 zeros and then 1. It's still 8 bits, which is less than a word. That's good. You might put 118. 118 means 0001. Then you have another 4 zeros. So this will be 16 bits, still less than or equal to 16. But you cannot put something like this, which is 30 more than 16 bits, 20 bits basically. 0001, 0001, 0001, 0001, then 1000. These are 20 bits. So that's not good. So the initial values that you put must match the data type that you have in size. Here are some examples for data definitions, like alpha. This is the name of the variable, name of the variable. And basically all these are names of variables. Here, byte, which is the data type. So we define here data type. It's not like integer or or float like C++. We define basically with a size. So all of these are data types. Data types, and all of these are initializers. So let's take them one by one. Alpha, byte, A. So here you are defining variable called alpha. Of type byte or 8 bits, and you give it, initial value, which is 8. So it's like a char character in C++. So you might put, a character as initial value. It doesn't have to be a number. Another example, beta, double word, which means a word is 16 bits. So this will be 32-bit unsigned integer, and you put 0 as initial value. Gamma, signed byte, and you put -128, as a value. Delta is of type word, so it's 16 bits, and you wish here not to put any initial value, so you must put, the question mark. Epsilon here, this is very good because this is a very good example. So this here you are defining an array of 3 locations or 3 elements. Let's say 3 elements. So, and each element has a value. So you differentiate between the values with the comma. So it's like 3 locations in the memory. The first location has, 10. Second location has 20. third location has 30. This is also another good example. Zeta is a variable name of type byte, and here you define a string. And for defining a string, you must append the string with 0. This will be like, the last location, we can say. So here you have 4 bytes, or basically 5, because the last one is 0. So Z, E, T, A, and you must put the 0 here. Another good example is this one, eta, again of type byte. Then you have here an array of 50 locations. So array of 50 elements or locations. Each location is 1 byte. And of course, it's not good to put 50 zeros. So you have here this directive duplicate. And here you say duplicate zeros, so the assembler will understand that here you're gonna put 50 zeros. So each location in eta array has a 0 as initial value. Theta, signed word, so signed, unsigned 16-bit integer, and you have this value for it. Finally, iota, it's a type of float or real 4. And this is the value for it. Good. Now, so what we have explained so far was about data definitions. Now let's check the instruction definitions or syntax. So any instruction in the code should have the following shape or structure. You have a label, and the label is optional. Anything between these 2 brackets means it's optional. You can put or not. Then you have a mnemonic. Mnemonic is just like an instruction, like move, add, Then you have operands. And again, the operand is optional because some instructions, some mnemonics doesn't have operands. Then you put a comment. This is for just user consumption, you might add or not. And again, it's optional. Here are some examples. So the first example is very good because it's an ideal, instructions syntax. You have here a label called the repeat. So a label is just like a name. So you are naming this line as repeat. You might put any name here. I choose repeat because most of the time we're gonna use labels to mark some line, and this line will be repeated in the execution, as we will see in making loops and stuff. Then here is the mnemonic, which here is just like it is move instruction, and this is the operands. We have 2 here. 2 registers, AX and AB, and AH, I'm sorry, this is AH. And finally here you have the comment. Another example, move, EAX and 32. Here you don't have a label, you don't have a comment, which is correct, or which is okay, because again the labels and the comments are optional. But you have operands because move takes operands. Add AX and 4 adds 4 to the value of AX and stores the value in AX again. Okay. So you don't have a label here, but you have comment. Call foo. This is another instruction or mnemonic that we're gonna see in the future. in which you are, asking the assembler to go to a label or line with a label foo, and this foo has some procedures there, some part of the code, some function basically that you're gonna execute. And call here is is an example of mnemonics or instructions that doesn't have operands. This is not an operand, this is a label. Move AX, temp and AX means move the value of temp in the variable. This is a variable. This is a variable defined, should be defined in data segment, in the data segment of the code. We're gonna see examples and this will be clear for for us. And here's a comment takes more than one line. So it's okay to have lines with just comments. It's very okay. Good. So here is some examples for mnemonics. We studied move, we studied add. Subtract is a new for us. It's just like add. So it subtracts one value from another. Multiplication is also a new one for us. Multiplies two value with each other. Jump is similar to call. You are jumping to some jump label here. So you should add some label. Like for example here, you might say jump repeat. Means go to the the line repeat. And the call is call for a procedure like call foo here in this example. Okay, here is examples for operands. You might have just numeral operand. You might have expression. We'll see this in the future. You might have a register. This all the these are most of the examples that we see so far with registers. And you might have variable like name count here, like this example. Here we have one of the operands is a variable. It's called the temp. And here is our first complete code in assembly. Okay. Some parts here we're gonna understand or we gonna use a lot. Some parts are just like we're gonna use but without delving very deep into their meaning. But we still need. But it's a kind of distraction to explain everything. So I'm gonna explain the main parts here in this code. Okay. So the first, two parts is actually like a template for us. It's like lab one. So this part, these two parts that I am putting inside square red square boxes is codes that will not change much from a program to another, or from an application to another, or a project to another. Okay, I mean you will have all the time that part. You will have all the time that part as well. Okay, you will have data segment. This might change. You will have a code segment, but again that might change. So the one in the between this box here, which is the remaining of the program, is the program itself, the actual code, the actual application. That of course will change from an application to another. Now let's go line by line. The first one, again, this is type of directive 0.386, which enables the assembler to use 32-bit registers, because some Intel architectures doesn't have 32-bit registers in the beginning, but newer ones have 32-bit registers and even 64-bit registers. Memory dot model flat dot model again is a directive. Okay, and it defines the memory models that we're gonna use. And again, this is it's enough to know just the definition here without delving deep into the meaning. Dot stack 4096. This is another directive which is dot stack. So this directive defines the stack size. So we're gonna here have a stack portion of the memory, and this portion should be 4 kilobytes. 4096 is 4 kilobytes. Exit process proto. This is again a kind of directives that define how we're gonna exit the program. So we will not also delve deep into this these directives. Dot data, it's another directive that defines the start of the data segment. Here is the data segment. So this is the data, or this will be the data segment. And here we put data initializers. So in here, you define, like an array. This array is called data in. So that's the name of the array, of the variable of type array. And this array has 5 locations. Each location is a word. So each location is 2 bytes. So this is one location, which has 1 H. Another location, which is a word, so 2 bytes, has 1 also. The third location has also 1. The fourth location is also a word, which has 1. And then the fifth location. So this is a location, second location, third, fourth, fifth. And all of them has 1. Fix this. Another variable that you define called sum. So sum is also a variable of type word, again 16 bits, and doesn't have initial, but doesn't have initial value. Code. Dot code is another directive that defines the start of the code segment. So this is the start of the code segment, and here is the code segment. This part here. Main proc or pros. This is for procedure. So our code is like a procedure, was like a function basically, or like the main function in C++ or C. And this code here defines the start of the program, or the entry point for the program. Every procedure or every main function, we can say, must have a name defined by the pros or proc directive. Then followed by the assembly language instructions, which are these ones here, okay, and ended by end pros or end b. And the proc and end b statements must have the same label. The label here is main. So this is the label basically. Finally, invoke exit process 0. This is another standard way to terminate the execution of the program. And again, we will not delve deeper than this for such directives. Okay, but this is something that we should add in our template, okay, from time to time. Finally, this is code here. This will be our topic for lab 3, which is very interesting, code in which you have 5 values and you start to make a loop, and this loop will add these 5 values together, basically these 5 values, okay? And this is the way to do it. And this will be the lab, our lab 3. So I'm gonna explain this in details in our lab 3. Thank you very much, guys, for watching this video, and see you in the next video. Bye-bye.